So hello students, this is the third video class of the chapter haloalkane and the haloarene. So in our last class we have discussed some reactions. Now one of the reaction is reaction with the Cassian and the reaction with the adhesion. These reactions we have already discussed in the last class. So look at these two reactions. The Cassian give the cyanide and adhesion give the isocyanide. So here K and X, Kx is removed. So K, R and Cn give the RCl. That is cyanide, also called the nitrile. And Ag and X, Agx is removed and it give the R and Cn. But the product is not RCl, it is Rn, which is isocyanide. So one give the cyanide, other give the isocyanide. So the explanation for these two we have already discussed in our last class. That is, one is ionic, this is Cassian is ionic and adhesion is covalent. One is ionic compound and other is the covalent compound. Now another two reaction is with KNO2 and AgNO2. So Rx plus KNO2 give the RONO and Rx plus AgNO2 it gives the RNO2. So here K and X, Kx is removed, here Ag and X, Agx is removed. So here also one gives the nitrite, other gives the nitroalkane. Now why this happen? This one give the nitrite, other give the isonitrite. What is the possible explanation? Now we are going to explain this. That is nitrite, one give the nitrite and other give the isonitrite. Now we are going to explain this question. It is with KNO2 give the nitrite, with AgNO2 give the nitroalkane. Why? Now let us explain this question. Now when Rx react with KNO2, it gives nitrite, RONO. This is because KNO2 it is ionic compound. KNO2 it is ionic compound. If we write the structure, that is K plus O minus N double bond O. This is KNO2. Structure of the KNO2 is like this: K plus O minus then O and O. Now when Rx react to this is act as a nucleophile O and O. Here it is acting as a nucleophile O and O. This part is acting as a nucleophile. Here potassium is not acting as a nucleophile because it is positive charge. Nucleophile means it is electron d species. So electron d species means here it should carry either negative charge or lone pair. So nucleophile means whose A is a nucleophile. So A should have either a lone pair of electron or A should carry negative charge. So any electron d species acting as a nucleophile. So here potassium is positive charge. Positive charge means it is not rich in electrons, so it is not acting as a nucleophile. O and O, this part is acting as a nucleophile. So Rx when react with this nucleophile, that is O minus N double bond O. Now here nitrogen and oxygen. This nitrogen and oxygen. Nitrogen is also rich in electron because it is it carries lone pair of electron. Oxygen is negative charge, so oxygen is also rich in electron. So now here two atoms are electron rich species. So here two atoms are two atomic site is acting as a nucleophile. So here this oxygen can attract to the alkyl group as well as the nitrogen can also attract to the alkyl group. Two possibilities is there. Either oxygen can donate the electron pair as well as nitrogen can also donate the electron pair. There are two possibilities. Now which one will actually taking place? Out of the two possible path, two possible attack, which is actually taking place, that is either nitrogen will donate electron or oxygen will donate electron. Now here if we compare their electron richness, which one is more electron rich, nitrogen or oxygen? Which one is more electron rich? Look at the nitrogen carries only lone pair of electron, but oxygen carries negative charge. So here oxygen is more electron rich as compared to nitrogen, because oxygen carries the negative charge and it has two electron pair. So there are two electron pair on the oxygen atom. So oxygen is more rich in electron as compared to the nitrogen. So although there are two possibilities, that is either oxygen can donate as well as nitrogen can donate, but out of the two possibilities only oxygen will donate, nitrogen will not donate the electron pair, because oxygen is more rich in electron. So here actual attack is taking place with the oxygen, not with the nitrogen, and as a result what is the product now? Oxygen will donate the electron pair and this alkyl group will be removed. So now here the oxygen alkyl group is bonded with oxygen, that is RONO. So we are getting RONO. So when KNO2 react with alkyl halide, we are getting RONO, because here oxygen will donate the electron, not nitrogen. Now coming to the next part, RX when react with AgNO2, we get RNO2. This is because Rx plus AgNO2. This is the structure of AgNO2. The structure of AgNO2. Now it is covalent compound. AgNO2 is purely covalent compound. So now here there are two electron rich site. Oxygen carries electron pair, nitrogen carries electron pair, oxygen carries electron pair. So there are two possible sites which carries the electron pair. So now this oxygen can donate the electron as well as the nitrogen also can donate the electron. Nitrogen can also donate the electron. So there are two possibilities, oxygen as well as nitrogen. Now which one will actually taking place, that is oxygen will donate or nitrogen will donate? There are two possibilities. Now if we compare their electronegativity, so here none of these atom carries the negative charge, both are neutral. So previously one is negative charge, other is neutral. So negative charge is more rich in electron. So oxygen is donating the electron. But now here both the atoms are neutral. None of the atom carries the negative charge. Now coming to the electronegativity, oxygen and nitrogen, which is more electronegative? Oxygen is more electronegative, nitrogen is less electronegative. So oxygen is more electronegative, so oxygen has less tendency to donate the electron. If the atom is more electronegative, then it cannot donate the electron easily. So here oxygen atom is more electronegative, so oxygen cannot donate the electron easily. So oxygen cannot donate the electron. So here nitrogen is less electronegative as compared to the oxygen. So now nitrogen will donate the electron, not oxygen. In our previous case, oxygen and nitrogen, oxygen carries the negative charge, nitrogen is neutral. So negative charge always a more electron rich. So here oxygen will donate the electron. But now none of the atom is negative charge, both are neutral. So here oxygen is more electronegative. So if the atom is more electronegative, it cannot donate the electron easily. So now nitrogen will donate the electron. So now the attack will takes place to the nitrogen, not to the oxygen. So now Rx plus AgNO2 attack will takes place to the oxygen and next part is leaving. So now alkyl group is bonded with the nitrogen to RNO2. So we are getting RNO2. Clear? So with KNO2 we are getting nitrite, NiTrite, nitrite. But with HNO2 we are getting nitroalkane. So this is the explanation for this. So we have explained the two reactions. One is KNO2 and one is KCN and HCN. Other is KNO2 and so now coming to the next reaction. The next reaction is the reaction with the ammonia. So Rx alkyl halide on treatment with ammonia HNH2. HNH2 is ammonia. So here H and X, HX is removed. So here R and NH2. So R and H2 plus HX. So it is amine. Alkyl halide on treatment with ammonia, we are getting the amine. Now this amine is 1 degree amine because here nitrogen is bonded with one alkyl group, so it is 1 degree amine. Alkyl halide on treatment with ammonia, we are getting 1 degree amine. But if this alkyl halide is taken in excess, if the alkyl halide is taken in excess, now if it is present in excess amount, then the alkyl halide, all alkyl halide cannot be consumed in the first step because it is present in excess. Some amount will be remain unreacted. The excess, as it is present in excess amount, so some alkyl halide will remain unreacted. So the unreacted alkyl halide will react in the second step. Alkyl halide is present in excess, so alkyl halide, the 100% alkyl halide cannot be consumed in the first step. Some amount of alkyl halide will remain unreacted. So the unreacted alkyl halide will now react in the second step. So now Rx plus this product RNH2, so NHR, so RNH2. So the unreacted alkyl halide will now react in the second step with the product of the first step. So this is 1 degree amine, so now here it is H and NH2, H and X, HX is removed, so RNHR. So RNHR plus HX. So here nitrogen is bonded with 2 alkyl group, so it is 2 degree amine. 2 degree amine. Now again this Rx, so here Rx is excess amount, so the unreacted alkyl halide will react in the second step. Again the unreacted alkyl halide will react in the third step. So Rx plus this product NARR. So NHRR, NHRR. So again H and X, HX is removed. So now this alkyl group will now bonded with nitrogen. So R this alkyl group will now get bonded with nitrogen. So Rn. So Rn. This nitrogen is now again has two alkyl group. So nitrogen already has two alkyl group plus HX. Now this nitrogen has three alkyl groups, so it is 3-degree amine. 3-degree amine. So first alkyl halide react with ammonia, get the 1-degree amine. Again it is in excess amount, so unreacted alkyl halide will react with the product of the first step. We are getting 2-degree amine. Again this unreacted alkyl halide will react in the product of the second step. We are getting 3-degree amine. 1 degree, 2 degree, 3 degree. Next again this RS. This unreacted alkyl halide will react in the product of the third step. Is NR3, nitrogen bonded with 3 alkyl, that is NR3. So in our 3 steps, the H and X, HX is removed, H and X, HX is removed, H and X, HX is removed. So now nitrogen does not has any hydrogen. So now the removal of the HX is not possible. So now what will happen? Now nitrogen has a lone pair of electron. So this lone pair will attack with this alkyl group and this halogen group is leaving. So now nitrogen has already 3 alkyl group. Again it get bonded with 1 alkyl group. So nitrogen is now bonded with the 4 alkyl group. So NR4. Now nitrogen have donate the electron. If a species donate the electron, it become positive charge. So nitrogen become positive charge. And this halide group is leaving. It is X minus. So N plus X minus. This is called quaternary ammonium salt. Quaternary ammonium salt. So this is the reaction of the alkyl halide with ammonia. So we are getting a mixture of 1 degree, 2 degree, 3 degree and quaternary ammonium salt. So alkyl halide, excess alkyl halide on treatment with ammonia, we are getting 1 degree, 2 degree, 3 degree and quaternary ammonium salt. Now here we are taking the alkyl halide in excess. Now if we take ammonia in excess, then what will be the product? Now ammonia in excess. So RX plus HNH2, it is excess. If ammonia is taken in excess, so here HNX, HX is removed, so we are getting RNH2, that is 1 degree amine. So here alkyl halide is not present in excess. So here in this reaction, alkyl halide is limited and ammonia is excess. So now as alkyl halide is in the limited, so all alkyl halide will be consumed in the first step. There are no unreacted alkyl halide. So now the unreacted alkyl halide cannot be reacted in the second step because there is no unreacted alkyl halide. All alkyl halide get consumed in the first steps. So here only one step, that is we are getting only 1 degree amine. So in the reaction with ammonia, if alkyl halide is taken in excess, then we will get a mixture of 1 degree, 2 degree, 3 degree and quaternary ammonium salt. But if ammonia is taken in excess, we will get only 1 degree amine. Now go to the next reaction, that is reaction with NaI. Reaction with NaI. Sodium iodide. So Rx plus NaI. Here X equal to chlorine or bromine. X equal to chlorine or bromine. Now what will be the product? This NaNX will be removed. So here it is R and I, that is Ri plus NaNX, it will be NaX. As for example, CH3, CH2Cl plus NaI. What will be the product? This NaNCl, NaCl is removed. So CH3, CH2 and I. So product is CH3, CH2I plus NaCl. So Cl in the reactant, here chloride group, chloride is there. In the product, here it is iodide. So chloride is a halogen, iodide is also halogen. So one halogen is replaced by another halogen. So this reaction is called halogen exchange reaction. This reaction is called halogen exchange reaction. One halogen get replaced by another halogen, so this is called halogen exchange reaction. So what is the product? Product is haloalkane. Ri is haloalkane. Haloalkane. So on reaction with NaI, we are getting the iodoalkane. So this is the reaction with NaI. Now coming to the next reaction. Next reaction is the reaction with lithium aluminum hydride. The reduction with lithium aluminum hydride. So Rx on treatment with lithium aluminum hydride. So this is a reduction reaction. Reduction with lithium aluminum hydride. Now reduction means addition of hydrogen. Addition of hydrogen is called the reduction reaction. So here this halogen group will be replaced by hydrogen. It is a reducing agent. It will supply the hydrogen. Lithium aluminum hydride, it is a reducing agent. Reducing agent means it will supply hydrogen. So this reducing agent will supply the hydrogen, and this halogen will be replaced by the hydrogen. So product is RH. This halogen group is get replaced by the hydrogen. That is, it is the addition of hydrogen. It is called a reduction reaction. So product is alkane. RH is called alkane. So alkyl halide on reduction with the lithium aluminum hydride, we get alkane. For example, CH3, CH2Cl plus lithium aluminum hydride. What will be the product? The halogen is replaced by hydrogen. So now also the halogen will be replaced by the hydrogen. So CH3, CH2, and this halogen will be replaced by hydrogen. So CH3, CH2 and H. That is, it is CH3, CH2. This chlorine will be replaced by the hydrogen. And CH2 and H, it will become CH3. So this is reduction reaction. So these are the nucleophilic reactions of alkyl halides. So we have discussed the nucleophilic reactions. So we have already discussed the reactions in our previous video. So all the reactions that we have discussed in our last videos, these reactions is falls under the nucleophilic reactions. So nucleophilic reactions of alkyl halide is complete. So in our next video, you will discuss the reactions with metal and elimination reactions. Clear? Nucleophilic reactions of alkyl halide is completed. Now in the next video we will discuss some reactions of alkyl halide with metal and the elimination reactions. Thank you.